Today we'll be going through on how to use Ansys Workbench. For the start, we have to open Workbench. So to start, we'll be focusing on static structural. So looking at static structural will be it's basically FEA, which is finite elemental analysis, and which is to simulate materials undergoing load and stresses. So to start, we need to determine our materials that we'll be using in here. So to start, we need to go into engineering data sources and go into Granta materials. Engineering data sources is basically your inbuilt materials that has been provided for you. So for our very first material that we'll be looking at is uh, aluminium rod 6061 T6. To add, just press the plus button. So moving forward, we'll be adding stainless steel. And you see stainless steel 316 anew. We'll add that as well. So using the Granta material that you have exported into your OneDrive, you can just simply press the 3 button in your engineering data sources to add the material. So it will just bring you to your file and you just show you a XML file that is in your one located in your OneDrive. So I have already inputted mine, and as such I have my PA6 glass fiber here. So click to add, and now we'll go into our project. So for geometry, just press geometry, import geometry, browse, and this is my geometry. The name will be different, but the geometry will be the same. So and as such, we'll move into the model. Double click model to open Ansys mechanical. And you can see the geometry is right here. For a start, middle mouse button to rotate your geometry. Control middle mouse button is to move your geometry. And lastly, scrolling in and out of your mouse wheel to zoom in and zoom out. Simple. Okay, now we'll be talking about the material set for each and individual parts. So looking at the geometry itself, on the left hand side, open the tab, and as you can see, frame and the door today will be the PA6 glass fiber. Following that, we have the bottom bracket. So for the bottom bracket, it will be strictly aluminium alloy, as it is a constant, and it wouldn't change to other materials. Similar for the wheel frame, but this time it is stainless steel. It is strictly stainless steel and it doesn't change at all. Only for the frame and the two doors will be changing from your aluminium alloy or your carbon fiber, your composite of choice. So after that, we can move into static structure and insert the forces. Before that, we can solve the mesh first. So right click on mesh and just press generate mesh. So once you have generated your mesh, it should look something like this. So now we'll move on to putting the loads on the trolley itself. So right click on static structure and press insert. So there's multiple things here, but mainly we'll be focusing on force and fixed support. So for the force, simply just press the top load and just press apply. Next, we'll put in 15 kg as it is the load that is mentioned in your worksheet, which is 147.2 newtons. And as such, but looking at the arrow, it is not applying the force on the material itself. It is pulling the material. So thus we have to change the direction. In which direction? Press the other arrow and apply. Now the force will be going on to the top surface. The second load will be located internally. As such, we have to remove the door. So select both doors and you can hide body. And moving forward. Oh wait, one thing I forgot. Going to geometry itself, you can select geometry and go under properties. This would show you the weight of the geometry itself being 18.3 kg. So now going back to static structure, we can input the second force. So for the second force, it will be located on the rails itself internally. So control left click to select multiple surfaces. So once you're done, just press apply and there'll be a total of 26 faces. So another method to define your direction of force is through components. So component is basically referring to your axis. As such, we'll be talking about the z-axis as it is the vertical axis for this. So go into the z-axis and put negative 882.9 newtons in the z component. And as such, it is acting downwards off top of the rail. Once you are done, you can just go into solution. No. Once you're done, insert your fixed support. So for fixed support, this is where you add your fixed support to hold in place your geometry. Press apply, total 16 faces. Once you are done, go into solution, insert your needed data. So first one is your total deformation, following that your von Mises stress, and lastly your maximum principal stress. Once you're done, just press solve. And as you can see, we have all of this data required. So using this data, we can just record it down into the table in your worksheet. And looking at here, the ender animation, you can just press play to see your animation. That's how the thing deforms. Moving forward, we can see where is the maximum and minimum location of the points. So for total deformation as seen here, you can just go into result, maximum and minimum. So it will show you that the maximum is located at the top and the minimum is located at the wheel bracket. And similarly, for equivalent stress von Mises, you can see that the max von Mises stress is located on the wheel bracket, is the wheel frame itself. As such, this data can be used for a factor of safety. So after after all of these are done, we can just simply go back to home and press report preview. This is to generate the report to be submitted together with your worksheet, and as such, just press print and print to PDF. File name, I'm using the book guide, but they should have a file name for you guys. And once you are done, you can just input all your data into your worksheet, and that's about it.